I want to talk about the concept of nuclear binding energy. Now, with nuclear physics and Einstein's mass energy equivalence principle, E equals mc squared, the mass of the sum of some parts may not be equal to the mass of a whole. So if you take two light atoms and stick them together, some of that energy could get released, which is what happens in the process of nuclear fusion. Some of that energy becomes internal energy in the process known as binding energy. So to calculate the binding energy of a material, the sort of energy lost from bringing together the constituent materials, what we could do is take the mass of the parts that we would start with, the number of protons in our atom, times the mass of a hydrogen atom, which is 1 proton and 1 electron, and then we'll add the nucleon number minus the number of protons, which tells us how many neutrons we have, times the mass of 1 neutron. And then our binding energy would be the energy of the parts minus the mass of the atom that we're looking at. So for a neutron, in atomic mass units, we have 1.008665 AMU for the mass of a neutron, and 1.007825 atomic mass units for the mass of a hydrogen atom. So carbon-12 has 6 protons, 6 neutrons, and it has a mass in atomic mass units of exactly 12. So to find its binding energy, I'd take my number of protons times the mass of a hydrogen atom. I'd take the number of neutrons times the mass of a neutron, add that together and subtract 12 atomic mass units, and I get a binding energy of 0.09894 atomic mass units. Now, every 1 atomic mass unit has an energy of 931.494 mega electron volts divided by the speed of light squared to make it a mass. 931.494 mega electron volts in terms of the binding energy itself. So the binding energy would be 92.16 mega electron volts for the case of 1 carbon-12 atom, and that works out to 7.68 mega electron volts per nucleon in carbon-12. Thanks for watching.